Alright, so we're going to do 6-6 today. We'll be in your note packet. I should have time today to stamp, and there's only a couple of things that I have to get back to people. But tomorrow you'll have a quiz. Okay, so tomorrow will be a quiz. And yeah, good to go. All right, let's get into it. Find the coordinates of the vertices of the new quadrilateral if we reflect it over that line. So we're going to reflect A, B, C, D over that line. What's the key to reflection?
Opposite reciprocal.
So what do we call that in one word? Perpendicular. So we got to be perpendicular into that line. So the first thing that we need to do is we need to find the slope of that line, right?
Yes.
Okay, what is the slope of our given line?
2.
Yes, on 2? Okay, so then what would my perpendicular slope be? Negative 1/2, because I can't just be opposites. I got to be opposite and reciprocal. So that's negative 1/2. Okay? So I'm going to be reflecting in that line with a negative 1/2 slope. So let's start with A. A negative 1/2 slope would normally be down 1 and right 2. But what's the other possible directions for it? Up 1 and left 2. Okay? And that helps us out because if I take point A and I go up 1 and left 2, I'm at my line of reflection. So then I need to go one more up 1 and left 2, and this would be the new coordinates for point A. Excuse me, A prime. So that would be at, what would those coordinates be? Or would the coordinates be of A prime? 1, 8?
Yeah.
Yep, 1, 8. Now I'm going to do D next. Up 1, left 2 puts me on the line. So up 1, left 2 would put me at D prime. What are the coordinates of D prime? Negative 1, 4. B prime. Up 1, left 2 once. Up 1, left 2 twice. Up 1, left 2 3 times. Puts me at the line of reflection. So up 1, left 2 once. Up 1, left 2 twice. Up 1, left 2 3 times would put me at B prime. Negative 2, 10. Negative 3? Oh, yep, you are right. Yep, negative 3. Point C, up 1, left 2, up 1, left 2, up 1, left 2 3 times gets me to the line of reflection. Up 1, left 2, up 1, left 2, up 1, left 2 3 times gets me to the point C prime. Negative 5, 6. And then we can just draw it. Well, you are running around a circular track. What fraction of a lap around the track have you run if the angle formed by your starting position and the center of the track and your current position measures, all right? So how many degrees would it be to go all the way around a circular track? 360, okay? So if this angle here, if that angle there is 180 degrees, how much of the track have you run around?
180.
If-
What did you say?
If that angle that's in there, if that angle in there is 180 degrees, what part of the track have you run around? What fraction of the track?
Oh,
A half. You run around half of the track. If that red angle is 270 degrees, how much of the track have you run around? 3/4. If that angle is 45 degrees, how much of the track have you run around? 1/8. Yep, 1/8. Half of half of half. If that angle is 72 degrees, how much have you run around? 1/7. No. One-fifth. Yep, you run around 1/5 of the track. Ivy, how'd you come up with that?
I just took 360 divided by 72.
And that broke it up into 5 equal parts of 72 degrees? Yep, and so you did one of them, so it was
Yeah.
1/5. Could have we done that on all of them?
Yeah.
Yeah.
But we didn't.
360 divided by 180 is 2. We ran one of those 2, so that's why it's 1/2. 360 divided by 1/4, that's not that easy, or divided by 270 isn't that easy. But we could write it as 270 divided by 360, right? And then we reduce that fraction, and it reduces down to 3/4. Okay? All right? Love it. Let's talk about regular polygons. Okay? So a regular polygon is a polygon, so that's a closed figure. Okay? A regular polygon has equal sides and equal angles. So everything in that polygon is equal. All the sides are equal to each other. All of the interior angles are all equal to each other. So if we have an equilateral triangle, the 3 sides would all be equal, and the 3 angles would all be equal, and in fact, they would all be 60 degrees. What we're asking is there a line that we can draw somewhere on that triangle, and it would reflect, when we flip that pancake, it would reflect onto itself. That's what's called reflectional symmetry. Okay? Is there a line that can do that? Let me get rid of my angles here. Is there a line that can reflect it onto itself? So right through that top vertice? Pick a color. Orange? Cancel. all my colors?
Oh, yeah, that's actually sorry, but it doesn't have to be.
So like that one? Okay. Does that give me reflectional symmetry? Yeah. Is there more? What do we got?
Through the bottom left, just draw a line straight.
Like that one? They want from the other one?
Yep.
Like that one? Okay. So yes, there would be reflectional symmetry. And how many? 3 of them. Okay. Now let's talk rotational symmetry. Does it have rotational symmetry? You think so? Well, let's see. Here's our fancy dancy Lynn's made over the top triangle. Okay. You don't know? Let's see. Here we go. We're rotating.
Yeah, that's what I think.
Why is it being goofy?
Isn't it supposed to rotate from the middle? Because
Yeah.
there is, right?
Yeah.
Yeah.
There should be. It should be.
Oh, yeah.
It should have. For some reason, I don't know why. It must be. It must have been in the copies that it elongated it just a little bit. But yeah, that should have been. Whoa, tap the brakes.
You're texting?
That should have been right there.
Oh, I didn't.
Yep. See, it's not even in the. It's in the copies. So there's one, right?
Yeah. It'll be all the three.
There would be 2. And then there'd be 3 if we include.
But 360 is not included.
Well, but this time we will, because then it gets us 3. Okay, so there's 3 instances, right? Okay. So how many degrees do you think it would take to rotate that? Because we could go 3 degrees clockwise or counterclockwise, right? Okay. So how many degrees do you think it would take to rotate it through? 360. We go all the way around once, right? Okay. But what about the other 2?
120.
How'd you come up with 120?
360 divided by 3.
Divided by 3, because there's 3. It lands back on itself 3 times, right? Okay.
That's why we had to do that whole thing.
What do you mean?
The whole thing in the beginning.
Yeah.
The track.
The track?
Yeah.
Yeah. Okay. So it has 3 total symmetries, and there's 360 degrees all the way around. Oops, I should put that the other way. Let's put that the other way. 360 degrees all the way around, 3 total symmetries, so that would be then 120 degrees. Okay. Now we got a square. Does a square have reflectional symmetry? Yes. How many?
4.
We did this one yesterday, right?
4. Yeah, 4.
Okay, what were they?
The diagonals, and then horizontally, and vertically.
Oops, I missed. Oops, I missed. Right? Okay. Rotationally, we did this one yesterday too, didn't we? Okay. How many total rotations did it have yesterday? We had 4 total ones, right? Okay. So what would the degrees needed to be for rotational symmetry? 360 total degrees to go all the way around. And there's 4 total ones, right? So that would be 90. Okay. Anybody seeing a pattern yet?
Not really.
Go with it.
Number of sides on the shape is how many,
For rotational,
yeah.
okay?
Isn't it like the angle on the, like for the square it's 90 degrees, right? And then for this one? Oh, I guess it was 60.
It was 60, yeah. So we could. I see what you're saying. Like how it was 60 degrees was the measure of each internal angle, and then we rotated it 120. This one was 90, so it worked out 90 to 90 here. Okay. All right. Let's put this pattern. Let's see what if that all works out here with a regular pentagon. Does a regular pentagon have reflectional symmetry? Yes. Okay. 5 times. There's 1. There's 2. 3, 4, and 5. Right?
I think Brayson's got it.
You think Brayson's got
I
it?
think Brayson's got it. Yeah, Brayson, you did it. Brayson knows what it is.
So yes on rotational symmetry.
Yes.
Okay, let's just see, because this is one of those goofy ones where it's not. We haven't talked about this one yet. Okay, all right. So if I rotate it through,
1,
there's 1, right?
2,
There's 2.
3,
There's 3.
4,
There's 4,
5,
and 5 gets me back to the start, right?
Yeah.
Okay.
It's 72.
So it's 72.
That's 360 divided by 5 total sides. Is that the reason?
You tell me,
Yeah.
because there's 5. There's 5 lines of symmetry, right?
Oh yeah, the lines of symmetry, not the sides.
Okay.
Or is it the sides too?
Because it hasn't the lines of symmetry been the same as the sides?
Yeah.
Yeah.
But like a circle has 0 sides and it has 1 line. Actually has. Never mind. I'm gonna say it.
So just so you know, a circle is not a polygon.
Oh, we're only talking about polygons.
Yeah.
Oh.
Yeah.
I'm
Yeah.
lost.
Because a circle has no sides.
Or it has infinite sides. Or none.
None, actually. It's a curve. Oops. Let me just jump.
Yeah, Grayson knows what he's doing.
I thought we had another page. What happened to my other page?
I'm like, why are there hearts on it?
There it is.
Okay.
Like I knew I had one. Okay. All right.
Reflection.
So a regular hexagon. So how many sides?
1, 2, 3, 4, 5, 6.
6. Okay. So how many lines of symmetry should we have? We should have 6, right? Okay. So give them to me. Through the middle of the top.
Every point to the other point.
All the middles.
Yeah.
And then all the points to the other point.
I think I missed the on one. And then
That to the next point, like right across.
so there, and there, and then there. Okay. Now I'll adjust my other lines. Whoa, whoa, whoa.
Is there like a funky one or are they all the same?
What do you mean?
Like,
Okay, so there's my 6 lines of reflection, right? 6 sides, 6 lines of reflection. Okay. Now, this is only true in regular polygons. Okay? This doesn't work for non-regular polygons. Okay? So, would it have rotational symmetry? Once, twice, thrice, 4, 5, and 6, right? Okay. So what would the degree measure be then? 60 on each one. So you rotate it 60 degrees and it's back onto itself. 60 degrees back onto itself. 60 degrees back onto itself. So on and so forth. Octagon. How many? 8. Okay. Corner to corner. And then the middles. Eight of them. So we have 8 times that we would click it around. Degree.
Yep.
How much?
45.
45? Nonagon. How many sides? 9. Okay, so how many lines of reflection? 9. I feel like I'm missing one. This one. Nine of them. Rotational symmetry. Yep. How much?
40.
40. All right, let's tie it together. Do we notice a pattern in terms of the number and characteristics of the lines of symmetry?
Yes.
Okay, what was the pattern for the lines of symmetry? Same as the number of sides? Okay. Again, this is only in a regular polygon. The number of lines of symmetry is equal to the number of sides. Okay. What do we notice about the angles of rotation for rotational symmetry?
Divided by the number of sides.
Okay. I'm going to call it the rotation gap because it's not just that one rotation, right? So I can rotate a nonagon 40 degrees and it'll end up on itself. I could rotate it 80 degrees and it would end up on itself. 120 degrees, or 160, 200, 240, 280, 320, and 360 would put me back. Okay? It's not just that one, it's all the multiples of that one until you get to 360. Okay? Let's take a quick peek at your homework. Okay. Smallest fraction of a full circle that the propeller needs to turn in order to appear in the very same. Okay, so that's looking for that gap. 12-sided figure. Here's your dodecagon. 12-sided figure. It's called the dodecagon. Okay. Angles of rotation. We can do all of that. Regular polygon has a rotational angle. Yep. We can do all of that. 3 and 4 are working backwards. Just so you know, it gives you the angle that it rotates. It's asking you to find how many sides it has. Love it. We can handle 1 through 6 for sure. 7's a reflecting. 8's a reflecting. 9's a reflecting, but at this time it's a triangle, not just a point. 10's reflecting a parallelogram. Oh, excuse me. Sorry, I had a little yawn there. 11's find the line of reflection. 12's find the line of reflection. That's it, isn't it? Goes through 12. Oh, nope, there's one more. Oh, and then we got some graphing inequalities. When we're graphing inequalities, what do we have to do? Shade them. Yep, it's not just graphing the lines on these, it's shading them. Okay? What about these two? 14. Is that just graphing the line, or do we have to shade there in 14? Yes or no on shading for 14? Ladies and gentlemen, put your pencils down. Pencils down. Everybody, actually, you know what? Truthfully, everybody stand up. Literally, I am explaining to you the homework, and no one's paying attention. So again, I ask the question, on numbers 13, what do we have to do? We have to shade because it's an inequality. Is number 14 an inequality? So are you going to shade it? No. Okay? You think you've earned the right to sit back down now? Okay, now, let's think about this. Do the words that come out of my mouth mean something to you? Or should they? Are you treating them that way? No, you're not. Okay? I asked you simple questions today about your homework so that you could do your homework without any questions. Yes? And all of you decided to do number 1 instead of listen all the way through. Correct? Okay? Smartest choice you ever made?